In 3.5, we're going to be looking at equations of lines. First, we're going to start off with slope-intercept form. So when we have an equation, we can put that on a graph by finding solutions to it. So solutions to an equation are things that you can plug in that will make the equation true. And if we plot all those points, the x and y points that we can plug in to make an equation true, for an equation like this, it will come out as a straight line. Now, if we take that equation and rearrange it so that y is by itself on one side, we get slope-intercept form. And the nice thing about this form, about having y by itself on one side, is that the two numbers near x tell us some things about the line if we have it in that form. So the number right in front of x, m, that's the slope of the line, so that tells us the angle of the line. And then this number being added, that tells us the y-intercept. So the y-intercept is the place where the graph crosses the y-axis. So on this graph right here, maybe a bit hard to see, but the y-axis is right here, and the x-axis is right here. And we're given 2 points on this line. One of those points happens to be the y-intercept, and the other point is nothing special, but it's just another point on the line. So we're told to write an equation of this line in slope-intercept form. Well, this is actually fairly straightforward. All we have to do here is plug things into the general form of the equation. So we know that y equals mx plus b, and that m is the slope and b is the y-intercept. So we know the y-intercept, that's right here. We've been given that on the graph. So that crosses the y-axis at 3. So that goes in for the y-intercept. So that's b. Then the slope we can find just by counting on the graph. So we can count down 1, 2, 3, 4 to get down to the same y value as this point. So that's a negative 4 because we're going down. And then to the right 1, 2. So that's negative 4 over 2, which we could then reduce to negative 2 over 1 or just negative 2. So then m is negative 2, so we put that in front of x, and there's the equation. Y equals negative 2x plus 3. Example 2. Write an equation of a line that passes through the points 6, negative 2, and has the slope of m equals 3. So again, we're going to take the general form of the equation, y equals mx plus b, and we'll plug in what we know. Well, we don't know the y-intercept, so we're going to have to hold off on that. But we were told that the slope was 3, so we can plug that in. Well, we're also told one of the points on the line. So that's 6, negative 2. So this is the x value. This is the y value. So we're told a point on that line, and we've gotten the equation in x and a y. Now, if we actually take this x and y value and plug them into the equation, you'll notice that the only unknown thing left would be b. So we can find b then if we do that. So let's take negative 2 for y and plug it in. And then we'll take 6 for x and plug that in. And leave that as b. So in this equation you can see the only thing that we don't know is b. So we can solve for b and find out what b is. 3 times 6 is 18. And then we could subtract 18 from both sides and we get that b is negative 20. So then going back to our equation, y equals mx plus b. M we already knew was 3, and now we know that b is negative 20, so we'll plug that in, and there's the equation. Example 3. Write an equation of the line that passes through the point 1, negative 1, and is parallel to the line with the equation y equals 2x minus 3. So we want an equation that is parallel to this one and goes through this point. Well, the only thing that we need from this equation right here is the slope. So this 2 right here, that's it. We're just going to steal that slope and use it in our equation. So we actually don't need this negative 3 at all. That is completely irrelevant. It doesn't matter where the y-intercept is. All we care about for this is the slope, because we just want a line parallel to it. We don't care how far it is away from the line. We just care that it's parallel. So again, we're going to set up y equals mx plus b. Well, we know what the slope is. We need the same slope as this line, so we're going to just steal the 2 from there and use that. And we don't know what b is yet, but we can find it. And we can find it exactly the same as how we did it in example 2. So we're just going to take this point and plug it in for x and y. So the y value there is negative 1. The x value is 1. And when we plug those in, then we get an equation that only has b as its only unknown. And so we can solve this equation then for b. So this is -1 equals 2 plus b. Subtract 2 from both sides, and we get that b is equal to -3. So then for our equation, y equals the slope, which again was 2, and then -3. And there it is. Example 4. Write an equation of a line that passes through the point 2, 3, and is perpendicular to the line with the equation -2x minus 2. So again, we don't care about where this line is. We don't care about what the y-intercept is, so that doesn't matter at all. All that matters is that the slope here is -2, and that we want a line that is perpendicular to this. So we're going to take the slope that is -2 over 1. I just took that -2 and put it over 1 to make it easier to take the reciprocal. So if we want a line perpendicular to that, we're going to have to take the reciprocal, so we flip it over, and then take the opposite of it. So if it's already negative, when we take the opposite, that's going to make it positive. So a perpendicular slope to a slope of -2 is going to be a slope of positive 1/2. So when we set up our equation, y equals then 1/2 x plus b. Again, we don't know what b is yet, but we can find that by plugging this point into the equation. So the y value is 3. The x value of is 2, so we'll put a 2 there instead of x, plus b. Well, remember that multiplying by 1/2 is really the same thing as dividing by 2. So what we really have here is 2 divided by 2, which is 1. And then we can solve this by subtracting 1 from both sides. So b is equal to 2. So then for our equation, we use the slope that we found, 1/2 x, and then plus the y-intercept that we just found, which is 2. All right, there's another form, well, there's 2 more forms of a line, but only one more that we're going to look at in this lesson. So this is called standard form of a line. And standard form is when you have both of the variables on the same side of the equation. So we're going to have some number times x plus some number times y equals some other number. That's what standard form looks like. So you can see here 3x plus 4y equals 12. That is in standard form. Now there's a couple ways that we can graph from standard form. One way that we can graph from standard form is just take this equation and rearrange it to get it into slope-intercept form. So that would mean solve for y, get y all by itself on one side of the equation, and then you could just graph from slope-intercept form. Or what we could do is we could graph it by finding x and y intercepts, and that's what we're going to do here. So if you think about what the y-intercept is, so that's where it crosses the y-axis, that's this line right here. So if we think about what the x value of any point on this line is, well, say we take this point right here. So the coordinate points of this is 3, 4, 5. Okay, so this is the point 0, 5. So the x value is 0, the y value is 5. This point right here would be 0, 2. This point right here would be 0, -3. This point right here would be 0, -5. We've got any point on this line has an x value of 0. And if you think about that, x values tell you how far you are to the left or right. So if you're not to the left or right at all, if you're right in the center here, you're at 0. So if we want to find where the graph crosses the y-axis, we can just plug in 0 for x. So let's do that. So let's find the y-intercept. So we're going to take the equation and plug in 0 for x. Well, 3 times 0, that's just 0, so that'll go away, and we get 4y is equal to 12. Divide both sides by 4, and we get y is equal to 3. So this gives us a coordinate point. We plugged in 0 for x, and then we got 3 for y. So 0, 3, that's right here. And then we can do this again for the x-intercept. So if we're looking at the x-axis here, we think about what the y value of any point on this x-axis is. Well, look right here, this is the coordinate point -3, 0, the y value is 0. Look at this point, this is -1, 0, the y value is 0. This point over here would be 4, 0, the y value is 0. Any point on this line, the y value is going to be 0. So if we take the equation and plug in 0 for y, then we can find the x-intercept. So 4 times 0, that is just 0, that goes away, and we get 3x is equal to 12. Divide both sides by 3, and we get that x is equal to 4. So again, this is a coordinate point, so we plugged in 0 for y, and then we got 4 for x. So that's the coordinate point 4, 0. And if we're drawing a line, we only need 2 points. So we've got enough to draw the line here. So we can just draw a line between those 2 points, and there we have graphed the line.